The strange part isn't that artificial intelligence is changing the world. The strange part is that most people don't actually understand what is changing. We see the outputs, right? We hear all these massive promises. But the actual mechanics beneath it all, they remain completely hidden.
Just look at the world right now. People are rushing toward tools. Every single day, thousands of headlines are just flashing across our screens about new frameworks, new updates. It's like we're experiencing this global sprint toward the surface. But very few of us actually pause to examine the machinery operating underneath.
And that brilliantly illustrates the trap. Courses, certifications, prompt engineering boot camps. It all just creates this massive maze of information overload. Take a beginner, let's call him Arjun. He looks at this landscape and feels completely paralyzed by what you could call identity panic. He honestly thinks he needs to memorize 100 different tools just to stay relevant.
Which really raises a pretty disturbing question. If information is absolutely everywhere, if tutorials are literally infinite, why do so many people still feel utterly lost?
Section 1. The illusion of tools and why the how blinds us.
At first glance, the path seems obvious, doesn't it? Take Sarah, a career switcher who's frankly terrified she's already too late. She firmly believes that AI careers have to begin with Python code, syntax, and memorizing imports. But the reality? AI careers actually begin with human structure. For way too long, our absolute obsession with the how has completely blinded us to the why. We've basically been taught to memorize the shape of the machine without ever actually understanding the pieces.
There's this wonderful moment where a wise mentor, Professor Orion, turns to a confused student and asks a simple question. When builders construct a house, do they begin with paint? No, they begin with the foundation. And really, why should intelligence be any different? A machine's output is entirely useless if the human mind hasn't structured the question first. So we really need to reframe our fears here. A lot of people view mathematics as this terrifying wall of equations designed specifically to keep them out. But actually, math is simply a gym for the mind. It teaches structure, relation, and logic. It's the skeleton beneath the story. And it becomes highly accessible once you start seeing it simply as a tool for training your own human logic.
Section 2. The Human Logic Blueprint. Mind before machine.
So what happens without this structure? Well, imagine Maya. She's an overachiever who collects certificates and courses kind of like trophies, and she's always looking for a shortcut. She genuinely believes that if she just feeds enough data into an algorithm, the machine's going to do the thinking for her. But here's the thing. Feeding data into a system without human logic doesn't create intelligence. It merely accelerates confusion.
Because before the computer algorithm, there is the human algorithm. You notice clearly, you name the object, you test a small example, and you review it before trusting it. These are the exact human processes that artificial intelligence is simply attempting to mimic mathematically.
True capability actually begins in silence. The first room is quiet because the mind must hear itself think. Long before you ask a machine to calculate anything, before you write even a single line of code, you are that quiet room. The human mind is the absolute essential prerequisite to the machine.
Section 3. The shape beneath intelligence and perceiving reality.
Reality is basically an island of entropy. It's wildly chaotic, and to a machine, it's all just noise. So how do we actually tame that? We do it with features. Features are simply clues that we extract from a data pipeline, which you can think of as a sort of river system of information. We have to stop staring at the infinite, overwhelming ocean of data, and instead, we start looking for specific, weighted clues that actually matter. Now, we obviously can't hard-code all the rules of reality. It's impossible, and that is exactly why machine learning exists in the first place. It's like a child learning from examples, guided entirely by probability. And try to think of probability not as some impossibly complex math, but more like a simple weather forecast. These systems are not born neutral. They learn behavior purely from the patterns and the specific environment that we choose to expose them to.
As Professor Orion so perfectly points out, AI learns from patterns. This means it is not pure magic. It is trained sensitivity to structure. The so-called ghost in the machine, it's really just layered decision-making based entirely on prior evidence. And when we demystify it like this, it immediately transforms from being something we should fear into something we can actively guide.
Section 4. Learning from small adjustments, the mechanics of improvement.
I know deep learning sounds incredibly intimidating, but it exists simply to build layers of understanding. Every single step just passes on a slightly more refined concept to the next. It's literally a chain of adjustable transformations. It takes raw clues, like, say, the varying shades of pixels in an image, and then, layer by layer, it builds them up into a recognizable concept, like a human face.
And this mathematical skeleton completely unlocks the whole black box mystery for someone like Arjun. Whenever you're facing a complex AI system, you just need to answer 3 basic questions. First, what is the input? Meaning, what exactly does the system observe? Second, what is the output? What does it produce? And third, absolutely crucially, what is the mistake? How do we actually know it got something wrong?
Because here's the secret. Without mistakes, there is absolutely no learning. Optimization exists because the system desperately needs a directional compass to know exactly how wrong it is. Think of it like trying to climb down a massive mountain that's hidden entirely by thick fog. You can't see the bottom at all. But every single error the system makes acts as a compass correction, gently guiding it one step further down the slope, closer to the truth.
So despite all the crazy hype around massive models and brand new frameworks, the core principles, they never alter. The architecture is really just new scenery. The mathematics of change, that fundamental reality of feedback and adjustment, remains the solid road beneath it all. It's like a lighthouse standing totally firm in a giant storm of passing trends.
Section 5. Creation with verification. Guiding the system.
Generative AI is not some all-knowing oracle. Maya finally realizes that prompt engineering isn't a secret magical spell you cast to hack the machine. It is simply structured human communication. A weak prompt is just lazy, something like write about AI. But a strong prompt brings real human intent. It clearly defines the purpose, the specific audience, the context, the form, and crucially, the precise limits.
And this gives us what we call the first principles loop. Prepare, ask, generate, inspect, revise, and test. We must never just surrender the truth to a generated output. The human workflow and our rigorous verification have to always securely wrap around what the machine gives us. At the end of the day, the machine suggests, but the human decides.
We've essentially deconstructed the machine just to find our own human logic sitting right there at its core. You see, you are not too late. The math is definitely not your enemy. But understanding all this leaves us with one final essential thought to chew on. If the machine can calculate the answer faster than we ever could, what kind of builder will you become to ensure you're actually asking the right question?